Welcome to BTEC Revision. In today's lesson, we're looking at resistivity and conductivity. By the end, we should be able to calculate the resistivity of materials. What determines the resistance of materials? Resistance is dependent upon a value called the resistivity, and length, area, and temperature, to name a few. Resistivity is a property that describes how much a material opposes the current flowing through it. Resistivity does not depend upon the length or area of any material. It only depends upon temperature, but we will keep that constant. It is important to note that resistance and resistivity are different, so do not get them confused. Here is the equation that links resistance to resistivity. Resistance equals resistivity times length divided by area. And the short form is R equals, its Greek letter is rho times length divided by area. The units are ohms for resistance, length is measured in meters, and area is measured in meters squared. Now, in order to work out resistivity, or rho, we will have to rearrange this equation. So we'll times both sides by A, which will give us RA, which is equal to rho L. Now we can divide both sides by L to give us rho equals RA divided by L. Now, looking at these units, we know R is measured in ohms, and area is measured in meters squared, and length is meters. And we can see the meters cancels out with the square, meter squared, which gives us the unit ohm meters. Each material will have its own resistivity value. Now, let's look at some examples for resistivity. Resistivity rho. The inverse of resistivity is called conductivity, and it is a property that describes how much a material allows the current to flow through it. It's given by this equation. Conductivity equals 1 over resistivity. The short form is sigma equals 1 over R. Looking at the units, we know resistivity is measured in ohm meters. So therefore, conductivity is going to be ohm minus 1, meters minus 1. Another unit we can use for resistivity is Siemens per meter. We can write that as capital S m to the power of minus 1. Therefore, conductivity will have the inverse of this unit, which will be meters, capital S, to the power of minus 1. Now, let's look at an example. A wire of length L equals 8 meters and a cross-section area A equals 1 times 10 to the power of minus 6 meters squared is made of a material with resistivity rho equals 2.5 times 10 to the power of minus 7 ohm meters. Calculate the resistance of the wire. Now, we know the equation R equals rho L over A. Looking at the units, they are all in the correct form, and the equation is in the correct form as well. So we can just plug in our numbers. So that would be 2.5 times 10 to the power of minus 7 times the length, which is 8, divided by the area, 1 times 10 to the power of minus 6. So plugging that in our calculator gives us a value of 2, and therefore that's 2 ohms. Now pause the video here and attempt this exam question. A copper wire has a resistivity of 1.68 times 10 to the power of minus 8 ohm meters. The wire has a length of 20 meters and a cross-section area of 2 times 10 to the power of minus 6 meters squared. Calculate the resistance of the copper wire. And the second question is, if the same copper wire is double in length while maintaining the same cross-sectional area, calculate the new resistance. Let's start with A, calculating the resistance of the wire. Now, this is similar to our example, R equals rho L over A. And we can just plug in the values, 1.68 times 10 to the power minus 8 times the length of 20 divided by a cross-section area, that's 2 times 10 to the power minus 6. And plugging the values in gives us a value of 0.168 ohms. Now, looking at part B, it says that the same copper wire is doubled in length. So we can times this by 40 instead of 20. And it says while maintaining the same cross-sectional area, so the bottom number here is the same, calculate the new resistance. Now, thinking about resistivity, we're looking at a copper wire, and that value stays the same for all copper wires, considering the temperature remains the same. And that's what we're going to assume in our specification. So we can keep this a constant, the resistivity, and we are going to double the length. So we can times this value here by 2. So that would be 40. And the area stays the same as it mentioned in the question. So therefore, we can just multiply our previous answer by 2. Therefore, the new resistance for question B, we'll write it fully to ensure we gain full marks in the exam. So that would be 20, and it's double, so that's times 2, divided by 2 times 10 to the power of minus 6. And we know that's just the double of our previous value, which is 0.336 ohms. And that's the end of the lesson. If you would like to boost your grades, visit us at btechrevision.com. See you next lesson.